Hello everyone, welcome to my channel. So in this video, I want to talk about how to use the Huff and Dalmas method to define the hospital service area. So it's in chapter 5 in our HSA book, the GS Automated Delineation of Hospital Service Areas, chapter 5. So before you start using this tool, make sure first you can download the data from my personal web page. And then second, you need to install some Python packages. So how to download the data and install the Python packages, you can go to see on my last video. All right. So first, open ArcGIS Pro here, create a new project, click Map, and then create a new project, for example, HSA book -CW2, and then specify the location where you want to save your project, and then check or uncheck create a new folder for this project. So in this video, I just keep using these default parameters, and then click OK to create a project. So in this map, there is nothing here, only the top map and here shade. And in the catalog pane, so go to the folders, right click the folder, add a folder connection because we want to connect to the data, Florida. Okay. This is the unzipped file. Then click OK. And then we can expand this folder, go to Florida. We see there are several data here. So this is for estimating public transit time. Audio flow data is to do some other analysis. I think this is for chapter 3. And then results are all of the results that I have done the experiment in the book, and then I just save the result for your reference. And the scripts are just the Python scripts, mainly the scripts for these tools. And then this is the main data FLHSAs. We can go inside, take a look. Dalmas HR defined in the 1993. Dalmas HSAs defined in 1993. And then this is the hospital data. This is the audio flows. And these are the zip code as well. And then we can go to ladder work. This is ladder work in Florida. And Google Maps Pro, this is used to estimate travel time using the Google Map Distance Matrix API. And then this is the HSA delineation tool on Huff Model Pro. This is mainly used to calculate for chapter 5. Since our beginning of the few sections for chapter 5. And then this is for adjust the spatial adjacency matrix. And these are some other files requirements .txt is a package we want to install. And the last one is for public transit time estimation. You can see all of this data are here and tools are here. So right now we need to use the HSA Delineation Pro. We have the Dalmas method. So in the toolboxes, we right click, we add toolboxes, we go to HSA Delineation Pro and the Florida folder, and then we click OK. And then we can expand this tool and see what's inside, build a spatial adjacency matrix. So this is a tool used for Dalmas, Huff Dalmas, or legwork community detection. Calculate regionalization indices mainly used to, like, you have the flows at the zip code level, and then you need the HSA, you have the HSA layer, but you want to calculate some variables like organization index, or average travel time, or say comparative population in the HSAs. You can use this tool, calculate the regionalization indices. Or if you have the flows at the HSA level, and then you have HRR layer already, and then you want to calculate the factors at HRR, you can use these two as well. Okay. So consolidated flows at the HSA level, this is used to create HR, especially when we have the flows at the zip code level, and then we want to define HRs. So first we need to create HSAs, right? And then we can use the demos or network community detection to define HRs. So here we can consolidate the flows at the zip code level to the HSA. Okay, so demos method for either define HSAs or HRs. You just need to make sure your very basic geographic unit are zip code or HSA. If you want to define HSAs or HR. So the last one, our community detection method, I have introduced how to use these two methods to implement different scenarios in another video. So if you're interested about this part, you can go to chapter 6, that video to look at how to use this tool. So in this video, I will talk about Dahmer's method. So this is the interface, input a polygon layer. If you have the zip code, you can input that. Unique ID, population, input edge file. This is OD flows at the zip code level. Origin ID, destination ID means the patient ID or hospital ID. Service flows means how many services patient receive from the hospitals. Travel time or distance means the distance or travel time that people are traveling from their residence to the hospitals. So you see the delineation method, we have a Huff demos method. That's what we want, okay? Input a spatial adjacency matrix file, threshold size. When you use that, make sure you specify the population field. And minimum localization index, this is for specify how many people will seek or how many people actually seek the health care in their local areas. Okay, so 0.5 represent half the population stay local, half of the population we are traveling beyond local. And usually we prefer a higher localization index, but here we can use 0.5 or 0, whatever other values as well. Output type is dissolved or not dissolved. Okay, either works. Dissolved means your final result will be HSA. Not dissolved, which means your result will be based on your input polygon layer with an additional HSA ID to specify each polygon will fall into. Okay. And output polygon layer, this is the result. So you will see we need to specify input spatial adjacency matrix. So I will not talk about that again. So if you are interested how to build a spatial adjacency matrix, use this tool. You can refer to my other videos to see how you could set these parameters to build a spatial adjacency matrix. And here, I think before I start using this tool to define HSAs as an example, I need to introduce a little bit about data, the typical area, and also audio flows. Like what I said in some other videos. So if you want to use the zip code area layer as a very basic geographic unit, make sure your OD flows are aggregated at the zip code level. If you use a census tract, your flows will be at the census tract. If you use grades, your flows will be at the grades. And then if you use county, and then your flows will be county. So they're always linked together. And then for the zip code area, you can open attribute table. You can see there is a zip code, 5 digits, and this is a Zoom ID range from 1 to 983. So make sure your Zoom ID start from 1. And X coordinate, Y coordinates are just the population weight centroid of the zip code area, because this one is more accurate than the geographic centroid to represent the population. Okay, especially for rural areas or less populated areas. And population is the population for the zip code. Population density, this is used for mapping. So there are 983 zip code. Make sure your Zoom ID start from 1. And another thing, don't use the object ID as a unique ID. Because this will raise the conflict when you use the tool. So if you can still set the same value, but you give a different name. For here, I use the Zoom ID, even though they have the same value like as the object ID, but I set a different name. Okay. Then we go to audio flows. We open the attribute table, so we can scroll right, and then we see there is a population Zoom ID. Okay, so this is the Zoom ID for the population zip code. So this is identical to the Zoom ID in the zip code area. And then hospital Zoom ID, the Zoom ID of the hospital zip code. Okay, it's also identical to the Zoom ID in the zip code area. And then this is a hospital zip code, X coordinate, Y coordinates. These are the population which is destroyed. They are of the zip code. They are identical to the zip code area as well. Okay. So patient zip code, the 5 digits, this is identical to the zip code here. And then hospital X, MC, hospital Y, MC represent the mean center of the hospital as a zip code. Okay. Because one zip code may have 1, 2, 3, 4, or no hospitals. So we use the mean center to represent the location of the hospitals in the zip code. Okay. All flows, which means the actual flows that patients receive from their hospitals. And this is for composite ID, like patient Zoom ID and hospital Zoom ID. Total time, this is how the travel time with patient traveling from the residence to the hospitals. And the potent is the Huff model. Population is just population for each patient zip code, and number beds means the number of beds for the hospital zip code. And potential, max potential, sum potential, probability, these are mainly for Huff model. Estimated flow based on the Huff model as well. Okay, so the purpose why I introduce how to use the Huff Datamos method to define the HSAs is because sometimes we could not get the actual flows that patients going to the hospitals, which means we need to estimate. Okay, we could use a Huff model to estimate the flows. So this is the estimate flow. This is why sometimes we want to use Huff Datamos method because we do not have the actual utilization data. Okay. So also for the audio flows, make sure when you create this table, make sure your patient Zoom ID, hospital Zoom ID, this pair, okay, these two pair, they are unique, which means here 1, 1, and then your composite one will 1, 1. And then there will be no second records represent 1, 1 for the patient Zoom ID and hospital Zoom ID. If there are, you need to merge them together to be one row. Okay, make sure there are no duplicate records here. So if you have 1 for patient Zoom ID and 13 for hospital Zoom ID, and then if you have 1 additional row, 1 for patient Zoom ID, 13 for hospital Zoom ID, merge them together. And then I think you can merge all flows here as well. And then your trial time, you could use average, that will be fine, or use minimum, maximum. Okay, so this is our data. And then right now, let's go back to the tool. Datamos method, you can input the polygon, zip code area, unique ID, Zoom ID. And then right now we have the population, we can specify the population. Input edge file, we need to go to the data, Florida, go to FL HSAs, and then we choose audio flows, click OK. And then we have the origin ID is patient Zoom and zip Zoom ID, destination ID is hospital Zoom ID, and then we have the service flow filmed, which is all flows. And then we have the distance. Right now we have the total travel time, and then we can specify. Oh, sorry. So for the service flow films, we should use estimate flow because we do not have the flows. Okay. So in this case, why I have these two films, like what I said, because in this study area, we have the actual flows, but sometimes you don't have it. That's why we use a Huff model to estimate the flow here. And right now I want to implement the Huff Dartmouth method here. So we need to specify the estimate flows for the service flow film. And input the spatial adjacency matrix because I already create a adjacency matrix, so I could use it directly. Okay. So I can go, there is a result. Okay, this is what I created. .mbz file. This is a very efficient file format to deal with a larger matrix. Threshold size we can set 100, and the minimum population, minimum localization index we can set 0. We can set long, okay, or 0.5. Both are fine. So output type we can have the dissolved one, which means our final result will be HSA. If we say the non-result, which means our final output will be zip code layer with one additional row, one additional column to specify which HSA the zip code falls in. And then here we just choose not dissolved, and then we choose, let's say .HSAs, choose 2, okay, and then we click run. And then we can view details. We see total number of nodes. This means the zip code is 983. This is the total population, total number of flows, 1993. You can double check. And then these flows, we use the maximum. Okay, when we use a Huff model to estimate flows, they could be one zip code, could be, suppose we have 200 hospitals, there will be 200 flows. But right now we only choose the maximum one. Okay, so the total number of service venues is the venues along the estimate flow. You see the number of destination zip code 230. And then the output Huff Dartmouth delineate 130 HSAs. So it only takes seconds, still very efficient. And then this result will be automatically loaded in the contents pane. So this is their JS layers. We can right click the attribute table. We can go inside, take a look, HSA. The value ranges from 1 to 113. Count and zoom ID represent how many zip codes in the HSA. Population represent how many population. And then AI represent the localization index, which means so this is the ratio of the service volume within the HSA or divided by the service volume originating from the same HSA to any other HSAs. So the higher AI, the more favorable. Estimated time, this is a, I think this is a weighted average trial time, consider the flows and also trial time. Number dzooms, which means how many destination zip code for each HSA. So usually we want to make sure each HSA contain at least one hospital. So because we already agreed the hospital as a zip code level, so here we just make sure we have at least one destination zip code. And compatibility is just the correct ratio of parameter and area. So this measure the regularity of the HSA and the higher compact value, which means the HSA are less compact. Okay, that means the smaller the value, the more compact of the HSAs. So these are some attributes of the HSAs, and then we can even right click. Go to symbology, we can go use the unique value, and then we could remove or choose a different color scheme. Choose show or, and then we could go here, and then we could add all of the HSAs, and then we can see how could they look like. You see, there are some dollar download dollars I should say here. So if you are interested, if you want to process it, you can continue to do that. If you just want to, maybe these are just some submarket, okay, some submarket. Yeah, so I think that's it. So if you want to set some other parameters, you can do that threshold, maybe add more. And then minimum localization index, you can totally do that. Just change the parameters and then you will get the result. I think that's it. So thanks for your listening. If you have any questions, you can go to my personal webpage and then find my email, send them an email, and then I will do my best to reply to you as soon as possible. All right. Thank you so much. I will see you soon.